Hi guys, this is my engineering project. This will be focused on electrochemistry, sacrificial metals, and galvanic cells. So the question that we're going to be tackling today, it's based off of this scenario. So a civil engineer is inspecting a coastal bridge and notices the steel support beams, which are made up of iron, are undergoing rapid corrosion due to the saltwater environment. To prevent further damage, the engineer decides to implement cathodic protection by attaching a sacrificial anode. So, using standard reduction potentials that I will be providing y'all, don't worry, determine which metal between these two, zinc or copper, should be used as the sacrificial anode to protect the iron beams. Calculate this, and you also want to calculate the standard cell potential for the resulting electrochemical reaction. So, some context, right? Right here, we just have a standard old galvanic cell composed of your anode cathode, oxidations at the anode, reductions at the cathode. Electrons move from the anode to the cathode, and then cations move from but use the salt bridge to move to the cathode, and anions go to the anode. So, you know, pretty cool. Corrosion, right? In the context of our problem, corrosion is just a redox reaction. Oxidation is when a metal loses electrons, and that's what causes rust and damage. Reduction is when a metal gains electrons, right? So to protect our bridge, we want to use a sacrificial metal, which is basically a more reactive metal that we attach to the steel. And because it's more reactive, it ends up, sacrificing itself by oxidizing first, which then pumps electrons into the steel beam, which helps the beam stay in a state of reduction, and it won't corrode. So let's look at the chart, right? We want to compare zinc and copper into iron. So we want to have a spontaneous reaction between the two species. So looking at this table, what do you think will be the ion that we will choose to react with our iron? If you chose zinc, good job. Now, why is that? So if you recall, E cell is equal to E cathode minus E anode, right? So what we want is we want a spontaneous reaction, right? And a spontaneous reaction is governed by a positive E cell. So we want to pick one of the two species that when reacting with the iron, right, you'll end up getting a positive reaction and, be spontaneous, and the iron won't corrode. So looking at the two species and comparing them with each other, right? Zinc has a potential of 0.76. Copper has a potential of 0.34. Excuse me. Copper 2 plus has a potential of 0.34. Looking at the chart, right? We know that when we're comparing two things, right? Anything below what we're comparing to will spontaneously react with that species, and anything above it, it won't be able to react. So, using this equation, we get this. We plug in our value for the voltage of the iron into the cathode, and then we use the zinc 2 plus as our anode, and we get a positive cell voltage or cell potential, and all is good, spontaneous reaction. Um, Iron won't end up corroding, and we are good. Thanks.